any more time, let's get going. Joern, I'll shut up and disappear. The stage is yours.
Thank you very much. So thanks folks for having me. So my name is Joern Stenkamp. I'm a HashiCorp solutions engineer, and today I'm going to cover the topic. There we go. How to enable self-service DevOps with Terraform Cloud. So let's make it a little bit bigger. There we go. So first, apologies. My colleague Marc-Steffen is on sick leave, so I wish him all the best to recover as soon as possible. On the other hand, this means I'm doing the presentation on my own. And usually, initially, this was planned to have more a little demo aspect in our presentation. So sorry for that. It will just be slideware today, but hopefully you will get the gist out of it, and feel free to drop any question at any time. And for sure, you can, I'm going to share the slide deck afterwards. So if there's anything that you would like to discuss later on, feel free to get in touch with me. So therefore, that's it. So again, what I'm talking about is the enablement from an organizational perspective, how we can enable development teams at scale with consistency in terms of that they're allowed to do what they should do, but also always aligned with kind of policies or within some guardrails, so that they only can behave and do things that are within that guardrails. So in other words, it's infrastructure as code pipelines as kind of landing zone for any kind of IT service. First things first, to cover a little bit more ground. So very quick, I guess we all face the same situation on the market, that some of kind of top priorities from IT organizations are at least three pillars. One is time to market. So development teams are forced to do things faster than before at breakneck speed, so that from the idea till delivery, till time to market is as quick as possible. Aligned with security and governance. So we have so heterogeneous environments. We have so many clouds. We have so many different resources on different runtime environments, like Kubernetes, like public clouds, like private data centers, like wherever. So this means, based from the yesteryears and the traditional data center, security and governance has to look different than before. And again, as said before, there's lots of heterogeneous environments, so we need kind of consistency and operational efficiency that is capable of handling all the new reality aspects of cloud, of dynamic infrastructure, of what we are currently facing. So before I jump deeper into what I'm going to do with infrastructure pipelines, let's first have a very little view on the life cycle of an IT service. So IT service is anything like an application, a platform, infrastructure, anything that an IT organization is delivering to make business value out of it. So, and the life cycle simply is deploy iterations of change, and finally the decommissioning or the deletion of this IT service. So these are at least the three phases. It always starts with phase one, the initial deployment. So starting from day zero and going forward to day one, where the IT service, in this example on the picture, it's a web application store, something that is just as acting as an example. So from day zero to day one, it's simple, the day one provisioning or the time to market. So it's an initial start of the entire life cycle of any IT service. Following by the second phase, the iterations of change and updates, where we do bug fixing, where we update applications, where we do whatever is necessary that this IT service can deliver value to the market. So, and finally, the last phase of an IT service is phase three. So where we decompose and delete all the resources because the IT service is still no longer needed. Covering this life cycle management and maybe the way how IT organizations have organized IT services in the past is something like project versus product related management. So nowadays, an IT service does not fit very well into the framework of a project anymore, just because a project is usually just the stage within the entire life cycle of an IT service, like the initial deployment. Another part of a project is resources, including human resources, are just allocated until the end of the project scope and not beyond. And project management focus is usually in controlling costs and not the business value. So this is more the traditional cost center approach compared to investment of, or what is called, forgot the name, but you got the point. So if we have the entire life cycle and make just segments out of it in terms of there's just one project for deployment, another one for an update, and a third one for something else, it takes huge amount of effort for organizations to get all the resources aligned back to the bench to make these changes happen. So therefore, an IT service behaves like a product and must be continuously maintained throughout its entire life cycle, instead of just having a scope of a slice of the entire life cycle. There are great books, for example, and maybe I can share also some book recommendations covering exactly that topic, project versus product. So let's come to the agile lifecycle management itself. So where agility means that we need something that is automated, versioned, and self-service enabled. Because nowadays we want development teams to do their job in their own pace with self-service autonomy instead of just having policy checks and security checks done manual in a manual process. So, and with that, and today we're talking about Terraform and Terraform workflows. This is for those who don't know what Terraform is. So Terraform's mantra or Tau is about workflow, not technologies. So with that, Terraform is widely known as the infrastructure as code tool of choice that is able to maintain any resource in nearly any runtime environment. With that, we simply have on the left-hand side development teams who are able to write infrastructure as code declarations. And these declarations simply run through Terraform as an infrastructure code interpreter. So it interprets the language and is able to create and affect resources in nearly any runtime environment. And a runtime environment might be Google or AWS or Azure or Kubernetes or VMware or whatever. So there is about more than 1,000 different providers that can be used within Terraform to affect the resources of this specific runtime environment. So with that, there's just a single language, a single infrastructure as code language that is capable to address all the 4 layers that any IT service is based on. It's simply infrastructure is 1 layer, security is 1 layer, network and connectivity is 1 layer, and at least the application code on top of that. So whatever you do, maybe you just need provider credentials to authorize and authenticate a provider, which is a secret you don't want to share with the entire world. Or there's network connectivity across different microservices that need to be maintained, or network connectivity across containerized workloads and virtual machine workloads, something like that. All this needs to be addressed in a consistent manner. And this is something that the Terraform is capable of. So at least Terraform is the tool that turns a code artifact through a consistent workflow into a runtime artifact and is able to manage the life cycle of this runtime artifact. So if we are talking about workflows at enterprise scale, we simply have, from an organizational perspective, always the golden people, processes, and tools. And the combination of those 3 is the enablement from an organizational perspective to do life cycle of any object that is important to them. Lifecycle management object is simply, again, an IT service, is, for example, a web store again, which is simply an application. Once we have the demand for a web store as an application from an organization perspective, we simply assign a development team or a group of people who are enabled or allowed, or their responsibility is to maintain the life cycle, do changes to make things happen. So the last question is, what are the processes and the tools how to get this done? And this is very simple. So since we have the conclusion on that we do it in an automated fashion, so the only viable option to do this at scale is infrastructure as code, which means the development teams doesn't have access directly to influence the resources on the runtime environment anymore. These teams are now forced to write a declarative infrastructure as code template that once it's executed, do anything else automatically. So in a way, you always have a defined software, a declaration of infrastructure that is capable to affect the resources. And with the lack of a version control system like GitLab or GitHub or Bitbucket, we also have already a single source of truth about infrastructure as code, like we have a single source of truth about any software with the likes of, or with the introduction of a version control system. Followed by, now we connect the specific version control repository to a Terraform workspace. And a Terraform workspace is the infrastructure as code lifecycle manager. This is the Terraform instance that is able to execute the infrastructure as code and make the declarative infrastructure as code part real world on the runtime environments. Beside that, I can now also provide credentials and other sensitive information within that workspace as securely stored variables. So simply said again, just imagine we use 2 or 3 different cloud providers with Terraform. We need to authenticate and authorize Terraform to use these resources, and this is simply done by provider credentials, for example. And we don't want to share provider credentials with the entire team, so we can simply inject these sensitive values into the workspace variables and enable such a workflow instead of enabling individual people by sharing those sensitive information. Another part is, now I can completely describe what the desired state has to look like in the real world, in a way that I can predefine what the state has to look like before it's getting done, before it's going out into the wild. So with that, I have a perfect place to write policy, to define the guardrails that are enforced before anything has been executed by infrastructure as code. So once the development team is writing something which is not aligned with the policy, the deployment will stop and it will not go live. So this picture, at least, is an entire infrastructure as code pipeline, because we have an ingress, which is a version control system, and we have an egress using Terraform and a workspace from Terraform to make the lifecycle management happen. So the only missing part is now that the development team pushes valid infrastructure as code into the repository, and it will be executed automatically throughout these pipelines. Automatically means there are also further approval steps, but these approval steps are optional. And once you already have a fine-grained definition, what is secure, what is compliant, what does security and compliance mean within your organization, there's no need for further manual approvals from a security perspective, for example. Using that at scale, we can simply have dedicated infrastructure as code pipelines for each and every IT service to continuously maintain its lifecycle management, resulting in DevOps or DevSecOps or GitOps self-service workflow with guardrails. So no manual security checks are necessary because anything can be automated. Do we have any questions already from the team, from the audience?
Nothing yet. As a reminder, feel free to use the chat if you guys want to drop anything. And if you do, by the way, please make sure that you're sending to everyone and not just to host and panelists so that everyone can see it, or otherwise use the Q&A.
Right.
Andrea just asked, can you give examples of the policies you mentioned?
Yes, I will cover it a little bit later with the slide deck, and please feel free to continue or to repeat the question if it's not covered, because it is there are so many options. You can grab anything.
Awesome. And Venkat, yes, the presentation will be available as a recording.
Right.
Jeff, how do you decide which config to put in workflow variables? So I think versus in console or Vault, for instance.
Can you repeat the question once again, please?
Yeah, you also have it in the chat in case you want to read it, but how do you decide which config to put in workflow variables versus in console or Vault?
Okay, got it. Yeah, so great question. But I would also try to write it down and to answer it after the following section of my slide deck, because I think it's more easy.
All right, cool. Then there's another one by Dharmesh, but I think let's get to your next section and then we can get back to the questions then.
So, yeah, got it. So next section is doing the same thing I have described before at scale. So building these pipelines in a consistent and repeatable manner, or in other words, now we use infrastructure as code principles to create infrastructure as code pipelines. And doing that can also be named or called landing zones, cloud landing zones, which is an interesting term in our days, because if there are 10 people in the room and we ask what is a cloud landing zone, I would assume we get at least 11 answers. So trying to demystify landing zones a little bit in terms of what are they used for. And a landing zone is for a helicopter or for cloud resources. And questions like who has access to create, change, or delete resources? Other thing is, what is the designated environment for an IT service to run on? Which region, which providers are allowed or disallowed? Other one is, are these resources within budget? So what is the actual costs of the underlying resources? Is there a limit, or can people enforce it to use the entire universe to create an IT service? Which resources are allowed or disallowed? Again, this is already covering aspects of what can be done through policy and policy enforcement. So at least anything, you can blacklist or whitelist resources. You can put an amount of cloud spend. You can define circumstances in terms of day of the week, or only if the third-party system is bringing back the answer, go for it and not anything else. These are all things you can cover and include in policies. In terms of cloud landing zones, these are all questions that need to be answered up front before a development team starts to begin their work. In terms, if you want to have self-service autonomy, you have to define all the guardrails up front to get rid of manual feature or security approvals. The implementation of these answers is already the landing zone. So if we enable our developers to use infrastructure as code pipelines, we have always step one, which means from an admin perspective, we have to declare all the runtime definitions in which a new IT service resides, including compliance security requirements, for example. Once this is done, and the admin executes the infrastructure as code that declares the landing zone and the policies, We have already step 2. The dev team can now use the resources provided by the admin. They can now start to develop the IT service with self-service autonomy. So the landing zone itself becomes the lifecycle management object, and the infrastructure and the team that is able to define the IT service within that landing zone is another lifecycle management object, which also means I can change, delete, modify during its existence without deleting and regeneration. So it's really powerful lifecycle management object. Followed by, again, now the infrastructure team or the dev team is able to push valid infrastructure as code declarations into the version control system repository. And again, this will be executed automatically. And automatically means further approval steps are optional. So you can have additional approvals or modifactor or whatever. But only things that are affecting the workflow in terms of who has the authority to change something or you need a special approval. If you have an automation for all of that, these approval steps are not necessary. In this example now, we just have a one-on-one relation. So we have an admin who is doing the heavy liftings to enable the dev team and just providing one repository that is connected to one workspace. So maybe this is a little bit too lightweight. So we can have another example. So let's now create the landing zone for an application or an IT service B. And we simply use the same methodology. In the admin part is declaring the infrastructure as code into a version control system or injecting these declarations using the API. Once done, we have, for example, a more sophisticated environment where we have at least 3 nested infrastructure as code artifacts that become together the entire web service B. So we simply divide it into the infrastructure part, the network security part, and the application part, just as an example. You can have 1, 2, 3, or even 20 of different nested artifacts that together make an application or an IT service. And here again, if these teams are now push the infrastructure as code declaration that is valid and secure, then it will be executed and we have our IT service B up and running. So even keep in mind and have a view on the structure. So this is now just one development team that is capable to address all the 3 different parts of a repository to stage and create the application, the IT service B. Which is also possible to have more a segregation of responsibilities in terms of we have 3 different teams with different access to those repositories to be more aligned, again, with segregation of duties or separation of responsibilities or however you want to name it. So with that, I can also ensure that the application team is not able to change anything from the underlying network and security part, and the infrastructure team cannot change nothing from the application part, and vice versa. So now it would be time with Mark, who's sick or on sick leave. Sorry for that, for a short demo. I can't provide it right now, so I just put the references of everything I have told before into this slide. So there is an API bootstrap script that can be used to inject the secret zero that is the initial infrastructure as code pipeline from an admin perspective. And another repository is the declaration of a landing zone, which is at least 3 different workspaces with 3 different version control repositories, some policies to enable the development team to use this kind of setup as a landing zone. Feel free to contribute. Feel free to share your thoughts. So you will find me on GitHub with Joe Stack, or you find me on LinkedIn with my name, Joern Stenkamp. So if you want to share your thoughts or have further questions, please feel free to get in touch with me. So to the Q&A section, and I've already one question that is on my mind is where to decide where to put the variables or where to declare the variables. Before I give an answer, I just like to ask Luca, is there anything I need to cover right now or any new questions or?
Nope, feel free to go for that. We have a few more queued up, but you can start with Jeff's question and then we'll get to the other ones.
Great. So let me simply jump back to the Terraform slide and I will try to do my very best on explaining where to put variables to. So the question is great because once you have this infrastructure declaration on the left-hand side, something that the dev team is using. So the dev team can write infrastructure as code from scratch. They can also reuse pre-existing infrastructure as code modules, which is nothing else than a template, where there's already an opinionated way of how these resources need to be together or nested together to be compliant with in your organization. Simple example, you can simply have a virtual machine, but from an organizational point of view, that virtual machine has to be with a specific SSH key or has to be connected to a monitoring system, has some dependencies, which are at least is nothing else than different resources that need to be connected together in a specific state. Once you use these kind of templates, the only way to affect the result of that template is usually done by variables. So you can give variables a default, so you don't have to declare them, or there are some required variables. So you need to provide a value to these variables. So with that, you can simply decide, I need 1, 2, 3, 4, 10 times the resources. I can also abstract where to run it, which region or which flavor, small, medium, or large, something like that. So nevertheless, what you are doing, what you are trying to affect, just because Terraform is capable of addressing all the 4 layers, Terraform is also capable of addressing Console or Vault or any other of our tools. With that, I can also use Terraform to inject or to reuse the variables that are interpreted by Console or by a different environment or runtime environment or different resources. So there's no answer. It makes only sense here or there. It's just the answer. You can variabilize anything you would like to variabilize and send the variable or the value of the variables through these workflows to the resources that need to consume that. Hope that makes sense.
I think it does, Jessa, thank you. All right, Dharmesh, any advice on where teams should store state? That is the team that we're enabling.
Absolutely. This is, again, this is not a Terraform pitch today, but state storage is done within Terraform. So currently, I'm talking about Terraform Cloud, Terraform Enterprise, not Terraform open source CLI, because then you have to maintain state on your own. Once you use Terraform Cloud, and there's also Terraform Cloud free tier, so a non-commercial free offering for practitioners to use nearly not all of the things I've shown you so far, but many of them. So you got an API, you got centralized state management, you got variables, you got anything except policy enforcement, because that's an enterprise feature.
Abhishek, how do you connect Terraform Cloud to different cloud providers?
How do you connect Terraform Cloud to different? Again, this is the provider enablement. So each and every infrastructure as code template on the left-hand side can use different cloud provider or cloud providers. So it's not limited to just have one cloud provider in that template. You can also have VMware, Vault, AWS, Azure, and because this is not a commercial, but these are maybe the 3 major cloud providers in Germany. there's no limitation on that. The only thing you need to do is you simply invoke these providers within the infrastructure as code declaration, and then you can use all the resources that are available through these infrastructure, through these cloud providers. And at least the beauty is you get one consistent language, the HashiCorp configuration language, which is very easy to read and learn and write. With the light of this language, you can easily address all the resources in a consistent and repeatable manner. So it's just a way, just the question of how many cloud providers do you use and authenticate within your infrastructure as code part on the left-hand side.
Let's see. Is the state of the landing zone workspace being shared with the other workspaces?
Yes and no. You can configure that. If you want to, you can share state across your other workspaces, or you can also say, no, the state is protected. There's no access possible on that state. And it's not limited to the admin and the other workspaces, because I just jumped very quickly to one of the latest slides. Let's reuse the bottom example. So it could also be you have three different aspects for the IT service B: infrastructure, network, and security and application. So it might make sense, and it usually does, to share specific information from the network and security part to the application part. Maybe the CRDR range, or the access and security group, or the VPC, or whatever. Those information can easily be shared across workspaces by sharing specific information of state across different other workspaces. Very easy. And therefore very secure, because there's no third-party system necessary just to share this kind of information. Even there's no real secrets management solution necessary to share sensitive information across different workspaces.
All right. Arthur is asking, is there a form in the pipeline to create a test for such infrastructure? So an example, if I want to check if a domain is working with a specific DNS or IP.
Yes, it is. As far as I now got the question, and maybe it's a little bit too small on that slide because this is a very condensed view of this pipelining approach. There are also run triggers in Terraform. So at least, and maybe you all know it, Terraform open source has two stages: plan and apply, nothing in between. That's it. On Terraform Enterprise and Cloud, there are additional stages like cost estimation, policy enforcement, and in between there's also something that is called run triggers. And run triggers can be used during the instantiation of resources just to check from third-party systems what information is needed from other systems to generate the real state on the runtime environment. And these run triggers can be used as a tremendous flexibility on these workflows. If you need information during the build time that is based on third-party system, which comes from the outside of those pipelines, you can easily inject it and integrate it.
Got it. Couple of questions from the YouTube. Any way to encrypt Terraform state file, making storing in Cloud Bucket more secure?
Yes, on open source, you have to do it yourself. On Terraform Cloud or Terraform Enterprise, it's already done and part of these offerings.
Mm-hmm. And do you recommend a monorepo structure for the suggested architecture that you showed?
Yeah, that's a tricky question because it depends. So we always have to go back from what would you like to achieve and then find the best way to address it within a version control system. So there's no one-size-fits-all answer to that question. It depends. Both is possible. You can use monorepo, you can use branching, you can have multiple repositories, whatever. You can have different subfolders within repository affecting different parts of your application. So there are so many possibilities. It's not limited to just one repo or anything like that. So therefore, again, sorry, please feel free to get in touch with me. We can discuss it any further, but it's not an easy answer to give.
Yeah, I feel like that's one of those like endless debates. Can you, Andre, can you give examples of the policies to check the IEC templates are good?
Can you give an example? Yes. So what Terraform does is, Terraform is planning anything that comes from the ingress part. But before it's doing the apply phase, it is able to check policy or policy sets. So it's not just the one monolithic policy that needs to be checked. You can also have policy sets in terms of, in that specific workflow, I need to check policy set A, B, C, D, E, and Z, but not the others. Doing these policy checks, it is so simple that maybe I can easily explain what it's doing. You can just define tests within that policy that are true or false. If it's true, the policy says it's good, go for it. If the policy check result is false, it will say you are violating against the policy, and then it will stop, or it needs further approval from a manual manager or whatever to override these policy enforcement. And now, with the like of the state files you generate once you do the plan from Terraform, you can also have an effect on the desired state when the plan would become true with an apply. So you get access to all the values from a real example within the plan phase of Terraform. And with that, you can address anything in any circumstance that needs to be true, that you say, yes, the policy is good, or the resources, the infrastructure as code is not violating against the policy. An example is you can blacklist specific resources or the large scale resources, or you simply say, hey, in my state or in my testing environments, you only got access to small to medium virtual machines or databases or whatever, because the large scale ones are limited to test environments or production environments, something like that. Or you say there is no change possible on Friday afternoon, just because we all want to have a nice weekend and no change in the system. Maybe the manager is able to override that and say, yes, this is an emergency case, so go for it. You can affect the costs. You can affect anything.
Is there a language to write these policies? Follow up by Andrew.
The language, if I got you right, yes, there is. It's called Sentinel within Terraform or within all HashiCorp products. This is easy to learn language, and there are lots of examples on our repository affecting all the cloud providers, having examples for many use cases. So it's its own language. It's a little bit like Go-like, but not that complicated. And even I was able, as not a developer, to learn it a little bit, or simply to reuse an available blueprint and change the things I need to make that policy the way I need it. Even policies live within a version control system, so you can use and define policies the same way you define infrastructure as code or do software development, because there is a single source of truth, which is living inside the control system. It's versionized, and you can assign policy sets and the version of that to those workflows. Very easy.
Let's see. Arndt, how are credentials to the cloud providers stored in Terraform Enterprise or Terraform Cloud?
Yeah, so there's a variable section associated to each and every workspace. and it's simply a key value store, as any variable is a key value. And then you are able to decide that this specific key value is sensitive, which means Terraform stores it, but you cannot read it back, and it will never be shown up into any log files from Terraform. So there's nearly no way that anybody else can read the value, a sensitive value, out of Terraform.
All right, let's go back to the Q&A because there's a few things here. How do Sentinel policies compare to open policy agents?
I was expecting that question. So once we started with Sentinel as a policy framework, it was limited to Sentinel. So we are working on opening up that you also can use open policy framework and then simply inject it into those workflows, or you simply use the run triggers, telling Terraform, before I go to the apply phase, I simply hand off the policy checks and enforcement to a third-party system. So it becomes something that is wherever in your environment and is simply telling Terraform true or false. So there are already implementations of handling this using open policy frameworks and integrate those into such a workflow. And there are also initiatives to make open policy frameworks available to Terraform in the future.
Let's see. There's a lot of questions. Is there any reference about automating cloud landing zone implementation, starting from an AWS account creation and some main policies application? So I guess I get started of some sort.
Now we get a little bit more my personal opinion on that, because nearly every major cloud provider has its own implementation of a cloud landing zone, which is absolutely good and fine once you decide, hey, AWS is my key in my kingdom. So there's absolutely nothing against the approach of using these cloud landing zone concepts. From Azure, there's one, on AWS is one. But going through the documentation and get this up and running needs a tremendous effort in reading and understanding, and is within the ecosystem of AWS. Again, this is completely fine. My approach is simply, let's get rid of all the heavy liftings and make it as lightweight as possible. And in my opinion, each and every landing zone at least consists of a version control system, a repository. You need a workspace or something that is maintaining the state of the resources. You want to inject variables. You may need to provide authentications, or you have some kind of secrets. And this is simply the bare minimum of any landing zone. It doesn't cover, in my opinion, or in my case, where does identity come from? It's more like, hey, identity is not my business, because with a version control system, I can easily decide, yes, there's developer A and there's developer B and C. They all have access credentials. They belong to the same group or team. They have the same attributes. So I can easily use this as the basis or the foundation for identity. Simply a GitHub account, for example.
For organizations that are new to cloud, do you recommend publishing reference Terraform code internally for development teams to start from, or trying to create modules with tunable parameters that developers can consume?
Good question. Our HashiCorp Tau is more like crawl, walk, run. So it's always good to have a template and a module to do something. But before you get there, you always start writing something, do some iterations of it, have some trial and error part, fail fast, recover soon and fast. And after a couple of iterations, you will automatically have something that looks like a module. or you even better know how to organize your infrastructure into modules to make this more consistent and more repeatable. If you start directly with modules and don't have enough knowledge in how to abstract your resources, you will have too many modules covering too little aspects of your resources, which becomes also unmaintainable in the future. So my recommendation is both start simple, and once you realize the complexity is not sufficient enough or whatever, you need to change something, go back and do some remanufacturing. You get better all the time, and your infrastructure as code, like any codification, will become better in the future.
Are the plan apply outputs rendered in real time, Matthew?
Whatever means real time, but yes. So once you run through the pipelines, you also get back the information. This is what Terraform is doing. These are the resources that are planned to be. So Terraform is creating a graph and a dependency graph, which resources has to be created in which order, not to run in a chicken egg situation. So once finished, you can verify the output of that plan, and once you fine with it, you can click the button and say, go for it, do the apply stage. But what I'm showing here in that picture specifically is you can also use this infrastructure as code pipelines without giving the developer teams any access to Terraform at all, because their demarcation line is a version control system. And the only thing that I've not shown in that slides for the ease of presentation is the feedback loop. Because from a workspace, you can easily define notifications to have this feedback loop back to your developer teams in terms of, another plan file, what is the status of your pipeline, is there any policy violation, is there any syntax error, something like that. So these are information you need to know to do better development. So this information can be transmitted to the developer teams by notifications, and the notification can be as simple as an email, can be a Slack integration, can be a webhook. So with one of those three, you can close that feedback loop to your developer teams so that information like plan, apply, policy enforcement, status of your deployment pipeline can be transferred to you, back to the ingress, back to your developer teams.
All right, we are pushing up on time. So thank you everybody for your questions and hanging around. So I think we have a couple more that we can get to. Can you plug third parties like Slack in that notification system? That's just a follow up from Matthew.
So once again, can you
plug third parties apps like Slack in that notification system?
Right. Definitely. Yes. Slack has a native integration to those notification system. Right. Yeah, you can.
Mm-hmm. And then I think last question for today, from your experience working with clients, do you have any advice for applying new policies to existing team deployments where the current deployments do not conform to the policy with a goal to be compliant within, say, 6 months?
So just for clarification, that means that you change the policies within the existence of the resources, or what does it really mean? Or
new policies to existing team deployments. So deployed resources.
Yeah, I don't really got that question right now, so I don't want to talk bullshit.
Well, I'm not sure that is even a real name. So if you want to follow up now to clarify, otherwise, if you guys have any follow-up questions or anything else that we couldn't get to today, I'm dropping here the link to the platform engineering Slack. Joern will join and will be available for any questions there too, as well as on I believe like Twitter and GitHub and LinkedIn. Sorry, but we'll send everything out in the email as well, in the follow-up email. So I love it, Jeff. But yeah, thank you, Joern. I think this is super interesting. People, I think, quite enjoyed it. There's a lot of questions. And thank you, everybody, for hanging around with us until now.
Thank you very much. Thanks for having me. Thanks for the good questions.
All right. Have a good one, everybody. See you the next